Hey everybody, welcome to PC Perspective. I'm Ryan Schrout, here with a special guest, Jani Joki, who is Director of Engineering, I guess, for Futuremark, now part of UL now, right? That's something that I don't know if a lot of people are aware of, actually. Has that changed anything for you guys, real quick off the top of the bat?
So no, not that much. I mean, we've been part of UL for about 18 months now. So since November a year ago. So
Okay.
actually more than 18 months now.
Ah.
But we're still mostly functioning as an individual entity. So
Okay.
like the engineering work is done the same way. Everything is pretty much done the same way. Just we have some opportunities that previously didn't exist, and of course have the backing of a very large company behind us for various endeavors. So
Very cool.
we're kind of getting the best of both worlds. We have like the big company benefits at the same time as the small company benefits.
Can't argue with that. So we wanted to bring you on here to talk about the new 3DMark Time Spy benchmark, and in particular, a feature included in it for asynchronous compute. Now, we already did a story on 3DMark Time Spy, and in fact, we kind of focused on the asynchronous compute because it was one of the first times that we've been able to have an application, whether it be a game or a benchmark or anything, allow us to enable or disable asynchronous compute and run kind of comparative tests back and forth between the two settings. So we did that. It actually had some interesting results. We saw that Pascal had asynchronous compute advantages. Maxwell did not on the NVIDIA side, but both all implementations of GCN appear to have benefits through asynchronous compute. Now, since that time, since the release, I guess you guys have had quite a bit of discussion directed your way about what asynchronous compute is, kind of how it's integrated into 3DMark Time Spy, enough so that you guys authored a blog post or a story, an editorial, whatever you want to call it, on futuremark.com titled A Closer Look at Asynchronous Compute in 3DMark Time Spy. Can you tell me a little bit like what spurred you guys to actually want to write this piece as opposed to leaving the information out there that was part of the reviewer's guide and that type of thing?
Well, we originally thought that the information that we included in the reviewer's guide in technical spec was fairly in depth on how we use asynchronous compute. But from the various feedback that we received, is to definitely see that there are still things that people did not understand, or it was not clear enough exactly what we're doing. There's also like a fair amount of discussion going on in various places. And one option would have been that we would gone to all the various threads around the world to like basically respond and try to explain to people on the questions. But we figured that it's actually easier just to collect the main things that people are asking and just like collect them in all one location and put it online. This is actually not the first time we've done this. I think it's 4 years ago. There's also similar discussions. Well, not quite as intense, but similar discussions on the iPhone CPU test. I don't know if you recall, if you covered that part. But anyway, we like there's a similar thing that people are wondering, like, why does the test behave in this way in particular hardware? And we did like an in-depth analysis and posted like a similar thing on it as well. Okay.
Now, you do start out the editorial looking at the benchmark or mentioning and discussing the benchmark development process and the design and principles. I know part of Futuremark's goals or goal when making these benchmarks is kind of like an open process, right? So it's fair to say both NVIDIA and AMD, as well as Intel and others, are partners of Futuremark in the development of the 3DMark Time Spy, right?
Yeah. That's the way we've been doing all the benchmarks ever since like year 2000. And honestly, that's the only way to actually do these benchmarks. We need to understand very well the hardware that is we're being tested, and of course, because we actually need to look into the future, we've been building this benchmark for almost 2 years now. Right. We started before DX12 effectively existed, and before any DX12 drivers existed, and to actually be able to do the work without the partner assistance and the discussions that we can have, it would be completely impossible.
And you do mention, like you saying here, that the aim is to predict the performance of games kind of going forward, which is obviously a very difficult task. And I'm positive, and you don't have to comment on this if you don't want to, that you're not making everybody happy with every benchmark you put out, right? AMD is going to have some concerns, NVIDIA is going to have some concerns, Intel as well, like things they would like you to do things differently that maybe are more advantageous to the hardware. But you guys are fairly confident in that the product that you put out as Time Spy is kind of like the company's view of what the future of games looks like, kind of with all of the input of all those players, right?
Pretty much, yeah. So of course, like especially in a benchmark like this, we've had like endless discussions over the last 2 years, especially in the last 6 months. So there's been a considerable amount of like discussion and predictions. I've seen lots of data from all vendors, and I've talked to a fair amount of game developers and like basically asked them like, so what are you going to do on DX12? How do you see this feature? How much you're going to use it? How much time you're going to spend on it, and so forth. And from all this information, we basically like collect up and like an image of what we believe that DX12 would do. Of course, we've also done benchmarks for a fairly long time, so we have a feel for the idea of how developers will approach different techniques. What I usually like to point out to people is that the game developers are out there to do the least amount of work for the maximum benefit. So they want the maximum performance for the least amount of work.
Yep.
No game developer is going to spend like a year optimizing something if it gives you 5%. But everybody's going to do the work if it's like for 2 weeks of work, you get like 10 or 20% of work, extra performance. And of course, game developers also want that it runs on as wide a variety of hardware as possible.
Yeah.
You don't want to like exclude people from playing your game because you do feature X.
Right.
So the thing that we do is a combination of all of these, and it's you're right. It's predicting the future is hard. We've been pretty successful in the past. Like usually, if you take an existing 3DMark that's been out for a few years, like Firestrike, and take a fair amount of DX11 games and compare their like relative performances to that one, if you average like the top 20 games, Firestrike predicts that actually pretty well. So we're of course hoping that that's going to happen at DX12 again.
Sure.
But of course, only future will tell us if that's actually going to be true. But I dare say that we put a lot of research into it, and I think our approach is going to be sound.
Gotcha. So the asynchronous compute implementation in TimeSpy, which is obviously just one of several DirectX 12 features that's kind of a standout in the product, but is one that's getting the attention today, is interesting in that it kind of changes how command lists and queues kind of stack up inside the GPU, right? You have this diagram on your editorial here that kind of attempts to demonstrate this, right, where you have your CPU threads going down into a copy queue, a compute queue, a 3D queue, and then different command lists that exist inside of that. And then those kind of pass synchronously or asynchronously, depending on the GPU and the framework, into the GPU itself. So when you were designing TimeSpy, what were the kind of decisions made, and like how do we implement asynchronous compute in a way that makes sense, both because we are a benchmark and we have kind of different setup processes than a normal game would, and also kind of being predictive of that future of DirectX 12?
So the image you showed is actually from the Microsoft MSDN.
Right.
So it's like directly like a Microsoft documentation showing how the different queues work. The queues exist in DX12 and they should be used. So I think from the developer point of view, basically your options are exactly how much work you place into each queue. You could stick everything into direct, which is the old one, effectively where you do the rendering. You can stick everything there, and it will work roughly like DX11 in that sense. The parallelism is going to be gone. You still get all the benefits of other DX12 stuff, like the lower driver overhead, but you can have tasks execute in parallel, or if the hardware so chooses, they can execute in parallel. Basically, by putting them in these different queues, you're declaring that I've taken care of the work so that these can happen at the same time, and my stuff is not going to be messed up.
Okay.
So from the beginning, we knew that we're going to place stuff into the different queues to make this possible. I think the most of the discussions that we've had is that exactly how much stuff we should put in, what other features we should put in, and in which order.
Okay, so if we look at in this diagram, the direct command list is probably it's the 3D one, right? It's equivalent to the 3D queue. So how? I guess when we look at this list was interesting to me. The work items in the compute queue in TimeSpy, particle simulation, light culling, environmental reflections. These are all things that you chose to implement in an asynchronous fashion, I guess predicting how game engines would use that same technology or that same feature in their engines kind of moving forward as well?
Yeah, as the name implies, it's like asynchronous compute means that it needs to be a compute work. So effectively, the whole work needs to happen in a compute shader. But most of the stuff you can do in a compute shader, you could also do asynchronously. For asynchronous to work, of course, it needs to make sure that it doesn't actually depend on some other work that's been already done, or that somebody's waiting for you to complete that work. If it does, then effectively you end up in a synchronous situation again. So we needed to select the areas that can be completed basically at any time before the next checkpoint, which are what the fences are for. Mm-hmm. And if you look at the diagram, you can see that we like distribute work, then wait for that work to like whenever it completes, then we can move on to the next stage, and then throw in a bunch of work again and wait for the next one.
Okay, so this diagram that is basically showing the workflow of process or of compute through the entirety of the game engine. This would look very different if you were building it under DirectX 11, right? It would basically be a single queue all the way down. You wouldn't have to worry about the weights, anything like that.
Yeah, exactly. You would have just the one queue and place all the work items into that one.
Okay. So that seems to make sense. Now, a lot of this article dives into a very, very complex application GPU view that is basically used by developers and driver vendors and you guys to some degree to kind of analyze your workloads, right? Analyze what the engine is doing, and how can you improve performance, those types of things. And you get very complex diagrams that look like this. Now, I don't want to try to educate people on what GPU view is to a minute detail or to a minute level here, but what is the idea that we're looking at here in GPU view, right? Is it you're seeing several different rows of sets of data that at the top here represent the queues, right? And if I can kind of zoom in here some, although I know you guys do that in the article, you can actually follow a piece of work throughout its lifetime, right? Essentially, correct?
Yeah. So you can see the work being done on the GPU. You can see the work being done in the driver. You can see the work being done in the application, like on the CPU side. So you can see the work that I've submitted. Because the way 3D rendering effectively in this works is that you submit work to the GPU to be completed. And with this task, you can see how it then passes through the GPU before it's actually does the work. There's a variety of reasons for using GPU. It is definitely like a professional tool. It's not designed to be excessively simple to use or necessarily even visually very simple to follow. But it is an excellent tool for a variety of reasons. And the reason why we chose to use it here is that a fair amount of users also use this, so we wanted to make sure that we use the same tool here as well. It's
a freely distributed application that is, I think, it's just part of the SD or the DirectX SDK. If you want to download it and look through it, anybody's welcome to do that. I know it is very complex to use and to actually look at and measure the data that it presents. But the first data set we have is from the GTX 970, and it shows that. I guess the important part here is that only a single queue is actually being utilized, right? Insinuating that asynchronous compute, regardless of what your game engine is set up to do, it's only taking advantage of one queue, right? And that's kind of the expected behavior, what we know the behavior to be with NVIDIA's current Maxwell driver support, et cetera, right?
Effectively, yes. So the main reason for this one is that because some people had raised concerns that on different hardware, we basically would not use multiple queues. That depending on the hardware, we would elect that, okay, we actually distribute all the work into a single queue, just like we would do in the X11. Mm-hmm. And the primary purpose of the 970 view here is to show that we actually do distribute the work into two queues. And the fact that the driver then elects to run them in a single queue is something that we have no control over.
Right.
That also explains, because some people are wondering, why doesn't it get a performance hit? Theoretically, this should happen if it's trying to execute two things at the same time, but it is unable to do so. But since the driver elects to runs them in a serial fashion, it makes sense that there's no loss. There's no benefit, right, but there's also no loss. So It runs just like the X11.
Okay, that makes sense. Now, looking at if I scroll down to the AMD Radeon Fury, we actually show if we look at the top here, you can see that there are two active queues, right? We have the hardware queue, the 3D queue, and the compute queue, and those are running in parallel. And you can kind of see how the flip and everything and the fences are working throughout this. What is there? Is there anything to the fact that the
I don't think so.
Okay.
So it depends on the work and the GPU itself. So,
Right.
so basically the purpose of this image is just to offer a comparison point to the previous image, showing that
there are two queues running.
we're distributing work to two different queues, and in this instance, actually, they're being executed in two different queues as well.
And we see the same thing on the GTX 1080, where you can see that there are multiple queues running, a compute queue as well as the 3D queue, and then you can actually follow that work down through the diagrams if you want to do so. And again, even though these diagrams do look very different, it is a lot to do with what the performance of the GPU is doing and how efficiently it is able to get through the work, that anytime you capture the data, it will look a little bit differently. So, and you do show if you disable it. Now, when you disable it in the game, if we disable asynchronous compute in the game, does that diagram, that DAG we showed at the beginning, that shifts some? It goes back into just basically putting all work into a single queue without the waits?
Yeah. So this is one of the reasons, like the benchmark has this functionality since we built it in, because we knew at some point we would need it.
Mm-hmm.
And for development purposes, we need it along the development. Of course, game developers don't necessarily have this function built in because it offers them not much functionality, or at least the final version of the game. So few games offer this, but we do. And basically, again, here, what we were showing is that when you actually switch off asynchronous and we intentionally put everything into a single queue, then the GPU view is quite different. Right. So this, again, to alleviate worries that people had that we're somehow treating different hardware differently. So that's not the case. The GPU views is very different when we intentionally then run with the asynchronous queue off.
Okay, that makes sense. Okay. And then again, with the 970, it actually looks in a single queue still. So, okay. I mean, this seems to make pretty good sense. So the takeaway from this is what? That you guys wanted to prove that you weren't treating certain hardware differently because it may not have asynchronous enabled in the driver. From the game standpoint, from the engine standpoint, from the benchmark standpoint, it's treating both scenarios the same, whether or not it's enabled or disabled in a driver.
That's true. So just like a game, our benchmark, like, honestly, it should not care. It should, we have amount of work that needs to be done, and so we distribute it, and then we expect the hardware underneath to do the work for us. So it would be inappropriate to treat different hardware differently in this instance.
Gotcha. And one of the pieces of feedback that we've gotten early is that there are going to be differences between how TimeSpy implements asynchronous compute versus how a game, an actual real world game would. What kind of are there any differences that stand out to you in like how you had to use asynchronous compute versus how a game would, that maybe it doesn't have the ability to preload everything that it knows it's going to need for the engine to run?
There's not that many. So when selecting which work we're going to put into the compute queue, we did talk to game developers, and pretty much the ones that we have running here is what we expect that most game developers will set to run in compute as well. Those are the easiest one and the smartest ones to do. Mm-hmm. So I don't fully expect that there's probably going to be game developers who attack compute more than we did. There's also going to be a whole bunch of game developers who do a lot less than we do. Making use of these technologies is definitely like an advanced technique.
Right. And
not everybody is going to be able to or want to invest the time to put it in. So it's hard to say. What we expect is that what we have is like a good rough average of what game developers will end up doing in the next year or 3 years.
Okay. All right. That seems to make sense. Well, that's pretty much it. I kind of wanted to give you guys the ability to kind of voice what your views were here, what the point of this story was, and kind of how the implementation of async in TimeSpy really worked. I think it's really interesting. It created interesting data points for us, I know, and obviously a lot of interesting discussions for our readers and everybody in the forums around, as I'm quite sure you are aware.
Yeah. That's interesting. Is definitely the word that we've seen.
Well, I appreciate you joining us. I know you're technically on vacation, and it's, let's see, you're about 6 hours ahead of us, 5 hours ahead of us, so it's very late where you are, so I appreciate you taking the time to talk with me this afternoon, and good luck, and I'm sure we'll have more to talk about in the not too distant future.
Oh, it's a pleasure to be here, and like I said, I mean, of course, it's a big worry for us if people do not understand how the benchmark works or are worried that it's somehow flawed.
Right.
So we poured a lot of effort into this. We've done many benchmarks, and we're like a professional benchmarking company. And every decision we make is something that we carefully consider, and every decision that we do is carefully vetted by our hardware partners. So the vendors who build the GPUs effectively review every single line of code we write. Usually many times across the development cycle.
Yeah.
And of course, like we just want to make sure that people understand this. We're not building this in a vacuum somewhere and then just to hope that it comes out right, or that it theoretically, even if we were to make mistakes, the hardware partners would notice them before launch. So the implementation that we've done is very carefully reviewed. And as such, I just wanted to make sure that everybody understands that.
I know more than most that the GPU vendors are incredibly particular about finding these types of things before launch. So, well, I appreciate the time and effort that you guys put into creating these tools for us to use and for the gamers to use as well. So, looking forward to continuing to use TimeSpy to evaluate GPUs in the coming months and years. So, thanks again for joining us.
Okay, thank you.
Bye. If you enjoyed this content, consider supporting in-depth technical content by contributing at patreon.com/PCPer.